Welcome to the discussion. Today we're diving into Anthropic's recent paper, Building Effective Agents. It's a fascinating look at how to build effective AI agents using large language models, or LLMs. Our guest is an expert in this field.
The paper highlights a crucial shift in how we approach LLM applications. It's moving beyond simple question answering to more complex agentic systems.
Exactly. It seems the key isn't just powerful models, but smart design.
Precisely. The most successful implementations prioritize simplicity and composable patterns over complex frameworks.
So let's unpack that. What are these agentic systems the paper discusses? The paper distinguishes between workflows and agents. Can you elaborate on that difference?
Workflows are essentially predefined sequences of LLM calls and tool usage orchestrated by code. Agents, however, are more dynamic. The LLM itself directs the process, choosing tools and steps as needed. Think of workflows as following a recipe, while agents are like a chef improvising within a set of ingredients.
That's a helpful analogy. So when should we choose one over the other?
It depends on the task. Workflows are great for well-defined, predictable tasks where consistency is key. Agents shine when you need flexibility and model-driven decision-making, especially at scale. Often, a simple LLM call with retrieval and in-context learning is sufficient. Only increase complexity when necessary.
The paper mentions several frameworks for building agentic systems, like LangChain's LangGraph and Amazon Bedrock's AI agent framework. What's your take on using these?
Frameworks can be helpful for getting started, simplifying tasks like LLM calls and tool integration. However, they can add layers of abstraction, making debugging harder and potentially encouraging unnecessary complexity. I recommend starting with direct LLM API usage. Many patterns can be implemented with minimal code. If you use a framework, understand its underlying code thoroughly.
So a bottom-up approach is preferred initially?
Yes, start simple and only add complexity if it demonstrably improves performance.
The paper outlines several workflow patterns. Let's start with the augmented LLM.
The augmented LLM is the fundamental building block. It's an LLM enhanced with retrieval, tools, and memory. The key is tailoring these augmentations to your specific use case and providing a clear, well-documented interface. Anthropic's Model Context Protocol is a good example of facilitating this.
And then we move to more complex workflows like prompt chaining, routing, and parallelization.
Exactly. Prompt chaining breaks down a task into sequential steps. Routing classifies input and directs it to specialized tasks. Parallelization allows for simultaneous LLM calls, either sectioning a task or running it multiple times for diverse outputs. Each has its strengths and weaknesses depending on the task. The orchestrator worker pattern dynamically delegates subtasks, while the evaluator optimizer iteratively refines responses based on feedback.
Finally, we get to agents, the most sophisticated type of agentic system.
Agents operate autonomously, planning and executing tasks independently, potentially interacting with the user and environment along the way. They're ideal for open-ended problems where the steps aren't predictable. However, this autonomy comes with increased cost and the risk of compounding errors. Thorough testing and guardrails are crucial.
The paper gives examples of coding agents and a computer use agent. What makes these particularly well suited for agentic approaches?
These tasks involve multiple steps, unpredictable subtasks, and the need for interaction with external tools. A coding agent, for instance, might need to modify multiple files based on a description, requiring dynamic decision-making.
The paper emphasizes that these patterns aren't mutually exclusive.
Absolutely. Developers can combine and customize them to fit their needs. The key is iterative development, measuring performance, and adding complexity only when it yields significant improvements. Simplicity should always be a priority.
The paper highlights 3 core principles for building effective agents.
Yes. Maintain simplicity. Prioritize transparency by showing the agent's planning steps, and carefully craft the agent-computer interface, ACI, through thorough tool documentation and testing. Think of it as investing in a good user experience, but for the AI.
That's a great point. It's not just about the model's capabilities, but also about how easily it can interact with its environment. The paper includes an appendix on real-world applications of agents. Customer support and coding are highlighted.
Customer support benefits from agents because they can combine conversational interfaces with tool integration to access customer data, knowledge bases, and perform actions like issuing refunds. Coding agents excel because code solutions are verifiable through automated tests, allowing for iterative refinement.
The second appendix focuses on prompt engineering for tools.
This is crucial. Tools are often essential for agents to interact with the external world. The paper emphasizes careful design of tool specifications and formats, minimizing formatting overhead and making them easy for the LLM to use. It's about creating a good agent-computer interface, ACI, just like designing a good human-computer interface, HCI.
So, to summarize, the paper advocates for a pragmatic approach to building LLM agents.
Exactly. Start simple, optimize with thorough evaluation, and only add complexity when necessary. Focus on clear design, transparency, and a well-defined interface between the agent and its tools. Frameworks can help, but don't be afraid to build with basic components for production systems.
It's about building the right system, not necessarily the most sophisticated one. What are some of the biggest challenges you see in building and deploying these kinds of agents?
One major challenge is ensuring reliability and safety, especially in high-stakes applications. Thorough testing and robust error handling are essential. Another challenge is managing the cost, as agents can be computationally expensive. Finally, there's the need for clear evaluation metrics to measure the effectiveness of different approaches.
And what are some of the most promising future directions for this field?
I see significant potential in improving the ability of agents to reason, plan, and learn from their experiences. More sophisticated tools and better integration with external systems will also be crucial. Research into explainability and interpretability will be vital for building trust and ensuring responsible use.
This has been a very insightful discussion. Thank you for sharing your expertise.